Okay, good evening everyone. We're going to start the lecture now. So as usual, I'm using the settings for the presentation slides. If you want to be on the slides, use the link shown above. So last lecture, we were introducing big data and some concept about big data. We reached this table illustrating some platforms that has adopted some solutions for big data. So here it's not meant to be a comprehensive list of all the technologies in the cloud related to big data. This is strictly cloud solutions. So there are other technologies, but like on-premise technologies, that's a different story. And here it's just showing you that how popular, how big platforms like Google, Amazon, Microsoft, they are all adopting big data solutions on the cloud so that they can offer it as a service for their customer, because they found out that there is a lot of traction, there is a lot of interest in these technologies, and hence they started to offer these technologies on their own as a service in their cloud. So as you can see here, like lots of these services, like for Google, we have for Google, they have their own technologies in terms of what some of these technologies were relied on to develop technologies like Hadoop. But Microsoft, Amazon, they rely on Hadoop, Spark, in order to populate these technologies on their cloud for their customers. So even that Hadoop or Spark are open source technologies, these vendors have decided to integrate them within their cloud in order to offer them as a service for their customers. So that shows that it's not only proprietary technologies for big data, but rather that even open source technologies have been adopted in the cloud in order to be produced as service for the customers. So that being said, let's go through some of these technologies, but this is more like technology specific, not cloud specific. In the previous slide, this is more cloud solutions, so cloud vendors adopting technologies and offering them as a service. But let's look at some of the technologies themselves, and we are going to go through these technologies in this course in details in the coming lectures. But here I'm just trying to introduce them to you so that you get a feel of what you are expecting to learn in this course. So this might be the most popular technology in the big data realm in terms of how it solved lots of problems, how it advanced the field of big data, allowing large data sets to be processed not easily, but more like efficiently and cost effectively. So Hadoop is an open source data storage and processing platform that can help big data analysts to ingest their data, store that data, and process that data in distributed fashion. So before Hadoop, things were like the organizations who are able to process big data, to store big data, they are only organizations who had invested a lot in their infrastructure. Because if you want to store a huge amount of data, you needed large arrays of hard drives in order to be able to have capacity and store that data. In order to process that data, the large amount of data, you needed lots of processing power to do that. So only organizations who had let's say, the capacity to do that were able to do it, while for, let's say, smaller organizations or even scientists like on non-profit organizations, it was harder to do that. So Hadoop has solved a lot of problems for that in terms of it's allowed for a lot of big data analysis and processing on a scale that do not need to invest cost effectively. You do not need to invest a lot of amount of money. So it's Hadoop, the nice thing about it is massively scalable. So you can start with few PCs, few virtual machines, or you can scale to 100 nodes, 1,000 nodes according to your need. So there is no, the starting point can be anything, your own PC, and according to your need, you can go on and increase the number of the size of the cluster according to the size of the data and your requirement in terms of speed. So it can scale easily, relatively easily, and at the same time, the starting point is not very expensive. So the Hadoop was based actually on some Google research. So In the beginning, the backstory is that there are two scientists, Cutting and there was another guy, I don't remember his name. So for them, they were looking at how they can create a system to ingest and process large volume of data. So they designed a system and they estimated that that system would take, like the cost of implementing that system would be around $500K. And the maintenance cost for that system would be around $30,000 per month. So and that would only allow them to process data in million of like terabytes, gigabytes, million of gigabytes. So for them at that time, it was ambitious, but very costly because $500K is not an easy amount of money that they, as a scientist, you can find. So while throughout their research, they stumbled upon a paper by Google describing what Google's named Google Filing System, GFS. So that drastically changed how they looked at things, and then through another paper looking at something called MapReduce, which is an algorithm that can help parallel processing. So they redesigned their idea in a way that made it much more cost effective and much more easier for implementation. So, and they call it Hadoop after the toy elephant of Cutting's son. And it relies on HDFS, Hadoop filing system, which is somewhat similar to Google filing system, and Hadoop MapReduce for processing. So for them, Google's paper, that's why, and they acknowledge the contribution of Google by saying that we actually think that Google are from the future and they are sending us messages. So this is strictly from Cutting's paper, mentioning the contribution of Google and that helped in developing Hadoop. So what's offered by Hadoop? So Hadoop offers redundant, fault-tolerant data storage. So that's like the base, which is like the most fundamental component, because like when you have big data, the first thing you need to think about is, okay, where do I keep that? And how do I make sure that it's like wherever I store my data is going to be in a reliable storage repository, and if something happens, I don't want to lose all the data, because specifically when it comes to data, you need to make sure that, okay, if something happens, if you are storing it on a hard drive and go wrong, do you lose all your data? So Hadoop, when it's the first thing and fundamental thing, it offers this redundant, fault-tolerant data storage. So that's simplified a lot of things, allowed big data to be stored on the Hadoop filing system easily and on a reliable format. And hence, like you store it, you're sure that, okay, there's some mechanism to ensure reliability and fault tolerance. And then you think about, okay, processing. So large amount of data, I need also to make sure that I have a way of processing that data, and I don't want to spend years processing amount of data. So that's why parallel processing would come in mind. So in that sense, Hadoop also offers parallel computation that can allow that data on multiple nodes to be processed. So when it comes to parallel processing, definitely for each process need to be on a separate route. So there need to be some level of job coordination and negotiation. So Hadoop also handle the job coordination, making sure that this node is doing its job, and that node which is not conflicting with another node. They are not processing the same data, and hence you do not waste your resourcing powers. So at the end, The programmers do not need to worry about where is my file, so is it this, how can I access it, is there a pointer, what's the starting point in memory. Hadoop will handle that for you. Any failures or data loss, Hadoop also, the framework, produce new nodes that take the data and hence recover any faulty nodes. And the computation in that sense, when it is parallel, so it's relatively faster. Definitely it depends on the size of the cluster, so how many nodes do you have. But on some level, it is faster than on a single node, on a single machine that you are trying to do. And the program in that sense, you don't need to think about, okay, how do I make a program that can scale on multiple PCs? Because in that sense, your software that you're developing, your program, will automatically distribute the logic that you're using, will distribute to all these worker nodes, and the logic that you have implemented is already executed. So you don't have the obligation that you think, okay, how do I distribute my software to do that or this? So in essence, like Hadoop would be cheaper. So you can scale to petabytes of storage according to using commodity devices. So that's the beauty also of Hadoop, that it does not require a specialized computer. It doesn't say you have to run me on this much processing power, this much RAM, or on this much hard drive, or and specifically you need to have RAID 5 or this. Hadoop it can run on commodity devices, and as much as these commodity devices you have, it will distribute the processing among them. So that's the beauty of Hadoop. It does not require specific specification for the machines. And whether you have your laptop, your friend's laptop, you can all install Hadoop so that all of these be worker nodes for your cluster. So in that sense, it is much cheaper than investing in a single PC with 16 core and 64 gigabytes of RAM or something like that. So in that sense, you can scale horizontally rather than vertically, making it much more cheaper for you to start. And faster because this expansion of multiple PCs, so parallel processing definitely faster. And in that sense, when you know that, okay, I have my data, it's distributed, it's fault tolerant, I can process it faster. So that's, it's very suitable for big data applications, because these are the things, the pain points that big data scientists have. Okay, I have a large amount of data and I'm concerned, where can I store it? How much should I pay for the storage? How much should I pay for the processing power? So all this, Hadoop make it more convenient for big data solutions or big data problems to solve these problems. So, that being said, can anyone in your own word tell me what exactly is Hadoop? So I talked about it for 3 slides now. You can, on the slides, this is a Word presentation, so you can print whatever you have in mind. So what is Hadoop? Is it a database? Is it a cloud platform? Is it a solution? Is it a game? Is it a social network? An elephant? Yeah, it is in a way an elephant, but we're talking big data here. So what does that elephant do? It is Hadoop. Whoa, we're going smaller and smaller. How can I get this bigger? SAS, distribution system, distributed big data. Whoa, we're going smaller and smaller. I should have my magnifying glasses now. Database system, efficiency and cheap. Yes, I can see someone is on the right track. Okay, so within the, it's hard to see, but I can say from really close, the winner ones are platform, database, data storage and processing platform. And there's someone who said a framework. Hooray for the framework per people. So Hadoop is actually a framework. So it is not a single technology. It is not a single software. It's not a single solution. It's a framework of solutions provided, like currently they are managed by Apache. So it's Apache Hadoop, but it's a framework of multiple solutions working together. The core of these solutions, as I mentioned in the beginning, when you're thinking of, okay, big data, so what are my pain points? So here comes the core of this framework is Hadoop file system, the storage, which is distributed storage. So that's one of the core components, data storage using Hadoop filing system. So as we mentioned, it runs on commodity hardware. So multiple laptops, you can all install this, and then voila, you have few terabytes of hard drive. And it is like you share that as a single filing system. So in that sense, it's horizontally scalable. So PCs together, they work as one hard drive when you can store your data. So this is from the storage component. The processing component, utilizing a technology called MapReduce. So MapReduce allow the parallel processing for between these nodes, the segregated nodes that you have. And the good thing about it is, in terms of, this is also one of the good thing about Hadoop, is that instead of like the normal rationale is that, okay, I take the data to the processing point. What they did is like the other way around, is that they send the computational logic to the data. So for each node that's storing data, the processing logic goes to that node in order for the data to be processed. So in that sense, there is less network traffic, and the node itself that's storing the data can do the processing, which also made things a bit more efficient. So other tools, like also when with this framework, other things that's like, because Hadoop filing system is a filing system, so it's a storage, it's a repository, but also it's not a database. So they build on top of that some NoSQL database, which is HBase, that can allow to manage that data properly. And in that sense, also there are other tools that can help. Pig, which is a scripting language for Hadoop, and also Mahout for machine learning. There are other tools that can help with this. I think I have better, this one. So as you can see, this is Hadoop ecosystem. So you can see here in the core, there is Hadoop filing system. there is MapReduce for the processing, and there is Yarn. Is anyone familiar with Yarn? I haven't talked about it, so this is if someone came across this. Has anyone came across Yarn? It's specifically for Hadoop, and like it's short for a really, let's say, simple phrase. So Yarn is yet another resource negotiator. There is no innovation in that there at all. So what Yarn is doing is just a resource negotiator, a scheduler for all these jobs, and that's the parallel processing jobs. So what Yarn would be doing is making sure that the worker nodes do not clash among each other, processing the same data, making sure that all these processing nodes, after they finish, they collect the results together so that it can be produced. So it's a resource negotiator that can manage all these parallel processing. So, and all these around, like when you see, these are the tools within the Hadoop ecosystem for data access scripting. Pig is very popular. Hive is, I think it was Microsoft. I'm not sure if it was Microsoft, but it was one of these big guys who created Hive, which is SQL way of querying the data. So for them, and they have a specific language, they call it HQL. So this is a way of accessing the data using SQL-like instructions. HBase and Cassandra, as I mentioned, this is more the data storage, the data management level. So HDFS is the filing system, while HBase or Cassandra, they can store that data and manage it. Lucene, also one of the things is here we're going to talk about in a bit, which is indexing and searching engine that can help you find the information. Drill and Mahout is also for this, data mining and machine learning libraries that you can apply on the top of the data on Hadoop. On the side, you can have a look at the data integration. So information, the big data are coming from somewhere. Most of the time it is, as we mentioned last lecture, it is not structured data. It is unstructured probably or semi-structured. So these tools like Flume here help you ingest the data from these semi-structured and unstructured sources in order to be able to categorize them and store them in, let's say, HBase. On the other side, you can see there are more organizers and schedulers like Zookeeper, the most popular one, that also make sure that like reserving time for each process, making sure that the schedule that Yarn has made is efficient. If one of the nodes has, let's say, stopped working, then it will, or was not responding for a long time, then the Zookeeper can deem that node like dead and then transfer the job to another node. So because with parallel processing, you need to make sure that all these nodes are well organized and they are working together rather than you just leave them to do their job without any monitoring. So all this, the Hadoop ecosystem are built on Java virtual machine. That's why it's useful since it is cross-platform. So you can install it on operating system, Linux, Unix, Windows, whatever you want. So that's also one of the benefits and you've seen already that when I showed the cloud solutions for big data. You can see that, let's go back and see. You can see that here, like when it comes to Amazon, they have their own implementation, Elastic MapReduce, which is also Hadoop. So for them, they have deployed the solution on their own system. Here also Caldera is also, they specifically install Apache version of Spark or MapReduce or Yarn. So here, because it is cross-platform, so it's relatively easier to do that and install it on different environments and different platforms. So when it comes to who's using Hadoop, a lot of organizations using Hadoop. So some of them are still using. Google have their own flavors. They are currently, the interesting thing about Google, so internally they say, okay, we don't use Hadoop in like as it is. They have their own implementation. They don't use HDFS. They have their own Google filing system. They have, in terms of like what we mentioned before as HBase, they don't use it. They have something called Bigtable. So they have their own flavor of the solution. But the funny thing is that if you go to Google Cloud, you'll find that they offer Hadoop and Spark as a cloud service for you as a customer. So internally, they are not using that, but they offer it for the customers if they like. Other organizations using that. Yahoo is one of the champions, actually, the champions of Hadoop. So because in the beginning, they were the bigger supporter for Hadoop, and they invested a lot into so that Hadoop can come as it is now. Any questions so far? Okay. So let's go to the second technology that we are going to look at in this course, which is Spark. It's interesting because there is some close relation between Hadoop and Spark. So as I mentioned in a little bit, MapReduce as a technology has helped a lot in terms of parallel processing. So Hadoop has relied on MapReduce in order to do the parallel processing in these different nodes. So it's for Hadoop from one side. MapReduce has helped with batch jobs, like, okay, you send, like you have this huge amount of data, you spread that in different nodes, each one take a chunk, start processing, and then, so it's more batch processing. So each one is working on their time, then when they are finished, they come together. So it's a more of a one-pass computation for Hadoop. So that's convenient as long as it is using commodity hardware. That was convenient for data scientists. But once it's got popular, it got more traction, people wanted more. So they were like, okay, we want multi-pass analytics. So we want the data to go faster. We want to read and write again and then read again. So it's not like a bad job, more like, okay, query, see results, change the results, or modify something, and then query again. So this was more multi-pass analytics. So in that sense, with Hadoop, it was like a bit challenging because Hadoop is storing everything on the file system. So it was not as fast as you want when it comes to this on the go. People also wanted more interactive ad hoc queries. So I want to get the results now. I want to know this on small chunks of data. I want to have an overview, a summary. So all these things, or like the data is not residing on your filing system, or like it's a stream of data and I want to analyze it on the go. So with all these, Hadoop was not really able to cater that, because Hadoop started with, okay, let's use commodity hardware in order to solve the problem of, okay, we don't have large processing units to do that. But when it comes to stream of data, interactive queries, or multipass analytics, that's made things make Hadoop a little bit not convenient for many data scientists. So in that sense, there was a need for a faster on-the-fly technology that can solve this. So when it comes to like our core technology, MapReduce, that can help with the parallel processing. So in general, it is more catered, more suitable for bad jobs, because what it's doing is like you get your input. There is MapReduce stands for, there are two functions. There is a mapping function. So imagine that number of students here, and each student have their own, they are enrolled in their own program. And then I want to calculate how many students in each program. So this is like a smaller scale big data problem. It's not a big, really big data problem, but on the sense that, okay, the mapping function, what it will do is map each of the students to the program. So you'll have a smaller set with map students like 30 to ComSci, 10 to Seng, or something like that. So in that sense, for each program, you have like the number of students mapped to that specialization. And then the reduce function is going to filter out, okay, in that sense, we need more specialization. So let's say comp something. So in that sense, the reduce function will be counting these, let's say, the mapped key value pairs in order to give you a straightaway answer that you have 10 in ComSci, 5 in Seng, this and that. So here it's when it is data that's on rest and you're doing that on a batch, one go, that's easy because you can split these data, like the number of students in each node will be calculated. This node will say I have 3 Seng. This node will say I have 2 ComSci, 1 Seng. And then later on, when they are aggregated together, the reduce function will be able to calculate quickly what is the result. So when it is as a bad job, MapReduce work fine because it is it is designed for this purpose. But here is like and it is implemented in Hadoop this way because Hadoop was targeting more, okay, data on disk. I read the data, calculation, give results. So for Hadoop and the way MapReduce is designed is fine because in that sense, I'm only going one way. I'm not going back and re-inquire the data or have multiple reads. So with this, it's like Hadoop and MapReduce work together fine. But what data scientists or big data scientists wanted is more like distributing or sharing the query between these nodes. So in that sense, rather than doing it on tier 1, tier 2, tier 3, and then giving results, I want to have results now, have results now, have results now. So I have the partial results from all the nodes, and then I can re-query or getting the information again. So it was more like I want the data to be more available on a faster way because I might inquiry the data again, which was not really a strong point for Hadoop. So in general, like for this to happen, you need lots of hard drives. So each one of them store that information. You need lots of CPUs and lots of memory. So for specifically being able to read on the fly, lots of memory is crucial because if it is on the drive, then there is some delays. Your reading of the drive, which is definitely slower than memory. Once you need reading a stream of data, manipulating that stream of data, making decision accordingly, then you need that data to be on your memory rather than on your drive. So here the memory plays a larger role than in Hadoop, which distribute everything on Hadoop filing system. So here comes Spark. So Spark tries to do that, to keep more data in memory in order to make that on-the-fly multiple reads and improve performance. So in that sense, this makes Spark more suitable for data stream of data or for more interactive query of your data. So there's also like Spark changed how the MapReduce is working. So instead of the reading of disk being on stages, now the nodes are more keeping the data in their memory, and hence there is a possibility to read the data faster. So it changed how MapReduce is processing the data in a parallel way. And Spark is also like, that depends on how you look at it. Spark tried to integrate the way it's working with functional programming rather than with the normal programming languages. So that's why they rely on Scala, which is a functional object-oriented programming language. There is some debate about whether it is better or worse, but for their own purposes, they rely on a functional programming language for that in order to make it more efficient in this sense. That made Spark faster, and the computation of data is like faster in terms of accessing memory data in memory rather than on disk. So it's up to 100 times faster than if it was on disk, like for parallel processing, which is 10 times only. And when it comes to using Scala, that's why they debate that it is faster, because the number of lines of codes is less compared to the number of lines of code that you need if you're using other programming language. Still, Spark have APIs that you can use using Python, Java, Scala, or even Scala. So you can use the API of Spark. You're not limited to only I should use Spark with Scala or it will not work. No, it has an API that allows you to do that, but for their purposes, they relied on the Scala API is rich and more interactive than, not more interactive, but rich than other programming language API. So Sparks allow this parallel processing and on-the-fly analysis of data on the memory of the nodes. So things get faster for some purposes. So Spark, being that, but you need to pay attention on something. It is not a modified version of Hadoop. So Hadoop and Spark, they coexist together. And and Spark on that sense also is not required to be running on Hadoop ecosystem. Spark still use Hadoop filing system because it's a distributed file system, and in the beginning you need your data to be on HDFS, on Hadoop filing system. But other than that, there is no requirement that they need to be working together. So it's only need the Hadoop filing system for storage purposes. So the question here is, does Spark replace Hadoop? So we said it's faster, it's giving you on the fly and allowing stream data processing. So does that make Hadoop obsolete? Does the need for Hadoop is minimized? '85, '86. Okay, so clearly we have more people saying Spark does not replace Hadoop. Can anyone share some idea why is that? So you said that they are both using HDFS, both use parallel processing. Spark is relying on more faster way of accessing data on the memory, so it is faster in one way. So why is it not replacing Hadoop? Can anyone share anything? Well, a few words and then Spark will start replacing Hadoop. So it's actually correct that Spark do not replace Hadoop. The core concept here is, as we mentioned, so Spark is faster. It's helping processing streamed data, streamed big data, but on the cost of larger sets of memory. So if your application, if your big data application requires you that you on the fly read the stream of data, provide quick analysis, more interactive, then definitely you need to rely on Spark, but at the cost of you need to invest in more capable machines to do that, because the data is meant to live in the memory, at least at the processing time. So if, on the other hand, if your application is like, okay, I'm fine with a batch job, I'm just interested into getting some insights from this data. I don't care if it's not streamed, so it's on rest. So for you, using commodity hardware is much more beneficial and more cost effective than investing in a bigger machine, more capable. So that's why it's like Spark is meant for some sort of applications, but it's not necessarily nullifying the need for Hadoop, which allow commodity hardware, which is seem like for specific application of batch jobs. So, yeah. So rather than we take a break, because I don't have many slides now, so let's continue so that you can go home early. So for notes, or do you prefer a break? Let's take that. So do you prefer a break, or do you prefer? I don't have much slides. I think 1, 2, 3, 4, 5, 6. Yeah, it's like it's a lecture. Don't expect that to have one slide. That's it. So 71, and we are now. Well, I only have 10 more slides. So do you prefer a break now, or you prefer to go early? Okay, let's go on. So the next technology that we are going to look at, which is very important when it comes to big data, is NoSQL technologies. So we mentioned before, in the previous lecture and in this lecture also, that's okay, the data, this big data that you are ingesting is not always in a relational format. It's not tabular format. Sometimes it's unstructured. Sometimes it's semi-structured. Sometimes it is structured, but not as much as you wish it to be. So NoSQL technologies, that's why they become key when it comes to storing and processing big data. So what is NoSQL? So the name stands for not only SQL. So it's not about no SQL, no SQL. No, it's not only SQL. So that's why, because it's do not rely on SQL as the primary querying language. So you'll find that there are some NoSQL databases that have SQL-like query language, but it's not specifically the same because there are less joins, that you don't use joins for NoSQL databases. The table format is different, especially with document format. It's even more different from relational database. So there are some differences that's more celebrated in NoSQL technologies. So the term NoSQL was introduced by Eric Evans at Apache Cassandra committer. So Cassandra is also a NoSQL database. So he spin off that term in order to make it a hype for Cassandra at that time. So, but you need to pay attention to something. So when I say it is interesting, it is good, it is useful on these purposes, it's not a replacement for relational databases. So you cannot say, although like at some point I've started seeing students going to NoSQL databases just for the sake of using NoSQL databases. That's fine as long as you find a good use case or you find some benefit in that, but the two do not replace each other. So there are, when it comes to transactional data, specific areas like for many-to-many relationship or between data instances, then relational database is more relevant. But in some cases, when it is one-to-many relationship between data instances, the NoSQL database or sometimes the document database become more attractive in that sense. It makes things easier. So it does not replace the relational database at some point, but it's complemented in some application areas that make things faster and more scalable. So NoSQL, when it comes, it's relied on relaxing one or more of the asset properties. So in that sense, there are some properties that we are used to in relational database, but with NoSQL, they become more like, okay, I can sacrifice some of these for the sake of higher speed or scalability or flexibility in schema. So the ACID transactional semantic ACID properties is automacy. So in the sense of, okay, is the data that I have when I do a transaction, the transaction is not committed, the data is not changed unless the whole transaction goes through. So that's in, let's say, banking sector is very important. So for them, they need to make sure that, okay, I don't want some changes in between credited and debits between accounts unless the whole transaction goes. So for some applications, relaxing these properties is not a good idea. But for some applications, when it comes to, let's say, social media, where you have a large amount of data and there is a fan-out effect when there is a data, like let's say for Twitter, when there is a tweet, and someone retweet it, and that person retweet. So there is a possibility of that single tweet being fanned out to a large number of people. So in that sense, speed and efficiency of getting that data take more priority than other properties. So in that sense, for traditional databases, although it has some really important characteristics, but these characteristics are more catered for specific applications, specific models that they work in together in a more efficient way. So in NoSQL, it is no relational by default. So it's not no relational in some cases, because you can see that if we're talking about graph database, which is also a NoSQL database, but in that sense, each node represents an data instance, and each edge is representing a relation between these data instances. So the relation is here different than tables, which are related by, and there is a primary key or foreign key. So there is a relation, but in a different kind of format. The good thing about, I'll not say the good thing, but more like the feature, one of the features of NoSQL database, it's not very strict about schema. So with the relational database, we all know that, okay, you need to design your schema, then you start putting your information. With NoSQL, it's more like, okay, you can have a general idea of what this document should look like in terms of what are the key value pairs in that document, and let's say the JSON document. And later on, even you can extend that document, change that document. There is no high restriction in terms of this schema should not change no matter what. In relational database, schema can change, but rarely that happens, and it's not really recommended. So when it comes to this, I think this one died. So let's go back to the leash. Where are you, leash? Sorry, Yep. Okay, we're back online. That's why you should not rely on radio mics. They get to be discharged. Okay, so let's just make sure that. Yep. Okay, so let's go back to this. I hope that the people on the video will not miss much. So in that sense also we talked about, okay, there is no restriction in terms of the schema that should not change. It can normally change. And hence also, like, one of the things that's one of the features of NoSQL is that data can be replicated, and that's like, if let's say for the sake of example, we're talking about document database, which is like MongoDB. So these documents can be replicated on multiple nodes and accessed as long as these nodes are referenced. So there is no problem of replicating that data onto multiple nodes. So, and also, like, you can on some level also the possibility of distributing that data into multiple nodes, having each node having portion of the data is also works. So because there is no, with document databases, there is no relation between one document and another. So that's why you can also horizontally increase the size of your database without the need of increasing the capacity of your hard drive. If any node is, let's say, faulty, you can easily replace that. So hence no single point of failure. As I mentioned, horizontal scalable. So cheap in terms of, since it is horizontally scalable and you can rely on some commodity hardware, you don't have to have high-end hardware. So it is cheaper in that sense. And like most of the solutions we are gonna talk about are open source. So it's not necessarily all the cases, but open source also have good investment in that, in the NoSQL data realm. So, and hence, since they are distributed, so writing to all these, to all these documents, let's say, on different machines is faster, so there is a performance thing. And on the other side, also the performance also affect on the level of one-to-many relationship of data instances. When you're trying, let's say, this is less big data, but more NoSQL. So let's say if your website and you're trying to load a whole document, rather than gathering information from segregated tables and then multiple joins in order to be able to fetch that data, you can load one document showing all the information that you need about some event or something. So, and there is fine granularity. So you can access specific key value pairs quickly without the document, so it's also provide better performance in that sense. So that's what I mentioned now about web apps. So other than big data, with web apps, NoSQL has become more popular in terms of there are some issues with the relational database, but still, as I mentioned, it's not like NoSQL is replacing relational, but in some instances, specifically when you are talking about how your application, your web application is handling objects, whether it is a JSON object or an XML object, so seamlessly taking that same object document in a document database and processing that objects makes things faster and more smooth in terms of how you're doing that, rather than have some translation layer that can read the data from your relational database and then map that to your object-oriented programming object. So there are some benefits for NoSQL. They do not replace relational, but in some cases, according to the application, according to the need, you might consider the NoSQL databases. So who are using NoSQL? So just this give you some indication that, okay, is this a popular technology, or is it just something the lecturer is talking about, trying to convince us this is good? So Google Bigtable, which it is their big data database. So instead of HBase for Hadoop ecosystem, Google has something called Bigtable, sorry. Bigtable is a NoSQL database. So they store tables. It's a tabular format database, but it's not relational tables. So it's a form of NoSQL database. LinkedIn, Facebook is using Cassandra, which is an open source product. Twitter is using HBase and Cassandra as well. So Baidu is using Hypertable, which is similar to Bigtable, but their own implementation. So all these, like you can see that they are using some form of NoSQL for specific needs. So it's not like they are diminishing relational data models, but on some cases, when it comes to specific use cases where NoSQL is proving to be better performance and easier to handle rather than relational databases, it can be efficient to rely on. So the last technology that I'm going to talk about is Elasticsearch. So Elasticsearch is it's a search engine think about it, it's not like don't go Google, but go as like a local search engine. So it rely on indexing data that you have. So let's say that you have your big data, big amount of data, and you want to query that data, but quickly on the level of, I want to, within this 1 petabyte of data, I want to, when I know that, okay, is that person lives in this area or not, I want some information quickly. So what Elasticsearch is doing, will be doing is indexing this data. So there is an indexing phase where it's going to index the data, where later on when you query that data, whether you use entities or whether you use the specific keywords using their API, it can provide you the answer relatively quickly rather than you going through all the, like with a normal database, going through all the, let's say, the fields in order to find your target. So initially it was released in 2010. So it can provide you with this distributed full text search engine, and it has a REST API, so you can implement it and then allow people to access it through a REST API. So like you can create your own Google engine. I'm not gonna say that it is on par with Google, but there are some services, some platforms using Elasticsearch, and they claim that we have created Google for cybersecurity. Check out there is a platform called Vulners. So they did that. They plugged in all the cybersecurity knowledge that they can find, and then implemented Elasticsearch on top of it. And then they say, voila, we can provide you Google for cybersecurity. So it works on some level. It can get you really good information, and it is specifically for cybersecurity information. So hence, it can be more relevant for your queries. And Elasticsearch is doing a really good job. So the answers, like the results of your query, is relatively fast. Elasticsearch work with JSON documents, so it is relying on NoSQL databases, on JSON documents. So in that sense, it relies on these documents. It indexes these documents, so later on you on a key value basis, so that it can later on access these documents and provide you with the results faster. It's developed in Java, so it's cross-platform. You can implement it on any platform you like. And also, like, one of the important things, why is it relevant for Elasticsearch? Because it also works on distributed manner. So it's not like it's a single node that can do this. Elasticsearch also, similar to Hadoop, try to create multiple nodes, and all these nodes take parts of the data and then create one index for all these data in these nodes. And when you're doing the query, each node is trying to find the closest match to your query and then providing you the result faster. So it is focused on scalability rather than on a single machine with single processor. So you can have it as on a parallel processing basis. So this is roughly how Elasticsearch, what's Elasticsearch ecosystem, how Elasticsearch works. So you have a cluster of nodes. So install your Elasticsearch on, and also you can install it on commodity hardware. So you don't have to install it on specialized high-end computers, commodity hardwares. Each hardware is a node within the cluster, and each node take parts of the data that you're trying to index. And then the index try to create, like the index will be taking information from all these nodes. For each of these nodes, you have a larger index, which you also have the possibility to split into smaller, what they call shards. So in that sense, even the index is spread out between the nodes. So it is more efficient and faster rather than the indexes on one machine and hence if that machine is has failed, or if it is overloaded, then everything slowed down. No, even the index is spread out between the nodes to make things faster. So as I said, like for cluster, the cluster is a collection of nodes, each servers, which is like can be your commodity PC. Definitely for each node, or for each cluster, because it's containing specific documents, it has specific name stored in these nodes. The data will be stored within the collection in these nodes, and then the indexing is for all these. Will be able to search for data in all these nodes in terms of what you're looking for. The node specifically is a single PC, so and it has the data that you allow to access and distribute. And for each one of these nodes, you can have the piece of data is indexed so that later on, when you're searching for something, it's faster to access that data. What I mentioned about the shard is the piece of the index. So it is a part of the Lucene. By the way, so Elasticsearch is, in case you're curious, it's based on Lucene, which is also, it's a search engine built on, based on, it's an Apache project. So Lucene is the, let's say, the core of Elasticsearch. Elasticsearch is applying more capabilities and APIs to handle the data, but the core of Elasticsearch is Lucene. So the index is actually a Lucene index. So just like if you're curious about what's the base of Elasticsearch, it is Lucene. So in that sense, these shards are part of the index, and the main index is the information about all the information shared between all the shards that you can collect to be able to find something quickly. So in that sense, since it is nodes and separated, it is fault tolerant, so there is no possibility that if one node failed, then everything will break out. Or if the index is residing on a single node, then if you lose the index, you need to start doing everything from scratch. Since it is spread between these nodes, the shards are spread, the index is spread, so it makes things more fault tolerant and hence more efficient for you, rather than caring whether I have this PC down or how I make sure that it doesn't. Elasticsearch is used in many applications. So in e-commerce, as I mentioned, like for that, it's because it's searching specific terms. So once you have your own index about information about a specific area, it can provide you better answers than Google, because it's actually looking at specific terminology that's relevant to the data you're storing. So when it comes to commercial uses, whether your use case is cybersecurity, when you have your data set as cybersecurity information, or it is web stores where you have your products or whatever you're selling on your platform, finding these with Elasticsearch is faster. So there are things other than that. Is you can autocomplete suggestions, so you can also, according to predefined sets of phrases, you can have suggestions for autocompletion. There are other use cases. You can have a look at them in terms of how you find statistics, how you find trends, and according to some things, how you do summarization, because when you are indexing, it can provide you some high-level information of everything. The index itself will provide you high-level information about what are these documents is about. So it's also used for summarization of data, and for definitely for analytics. You can use it for, like, if you have documents, specific documents, or you're searching specific things, then these data can be fetched easily rather than doing a large-scale keyword search, which will take longer time. So this is a list of all the people using Elasticsearch, showing you that it's not something small in terms of usage. It is very popular because people has find that it is useful for specific use cases when you have a more directed data set. So Elasticsearch worked very fine in that regard. Any questions so far? So these are roughly the technologies that we are going to cover in this course. So we're going in details in the coming weeks to try to cover each one of these, and we'll have lab activities and tutorials trying to practice these technologies, specifically Hadoop, Spark, and Elasticsearch. We'll have activities. These activities are very closely related to your assignments, so please, once we release activities in week 3, try to attend. By the way, just excuse me before you spread out. In regard to the Java refresher labs, I still haven't got approval from the school, but I'll keep you posted on the on WebCMS. So once we get approval, I'm asking for 3 labs, so that we'll have 3 labs next week as a Java refresher. So this would be more like Java for big data. So we're not going to teach you everything about Java. We are going to teach you some relevant things that you can probably use during the course, because this is not a programming course and we cannot invest much time on Java rather than 3 labs. So I'll keep you posted on WebCMS, and thank you all for coming today, and have a lovely night. Thank you. Nice.
The lecture recording is still available in the ego.
Yeah, I found that strange because I'm not sure. Like, did you find anyone else with the same problem? Because from my side, it is available. It's telling me it's available for students, and it is visible. So other than that, I don't know what I should do rather than this. So have you asked if anyone is having the same problem? So if it is a general, I can escalate to the school.
Let me ask my friend.
Yeah, can you just please check? Exactly. So Elasticsearch creates one index, but for the sake of redundancy and fault tolerance, it's split that index into smaller shards on each node. So just in case if this node has fallen, that doesn't make you have lost your index. You just replicate that node again, but you don't go from scratch because the index is partially there. So the shards are part of the index for Elasticsearch.
If I want to get like one data, like one data has one index.
No, not one data.
Database.
Yeah. Okay. So we're gonna go in details in Elasticsearch, but let's say quickly. I hope that's how clear. So what Elasticsearch is going to do is you need to provide some sort of initial index, and then it's going to go through all the JSON documents and try to map all these key value pairs as within the same index.
Okay.
So in that sense, when later on you say Australia, I'm looking for Australia, and then start to look at, okay, within the index, what are the documents that have Australia? So, and then give you all the documents that have Australia. Definitely you're not gonna look at only single document, but let's say, in that sense, you're saying Australian days or something. So it's gonna try to find these two indexes in a single document and then try to tell you, hey, these three documents have Australian date. So probably whatever you are after is here. So it's a faster way of giving you the whole document rather than, so it's not, you're not querying for field, you're querying for a bigger, for like a whole document rather than this. Yeah, we have a tutorial and a lecture about Elasticsearch, so don't worry if it's not clear now. Hopefully it's going to be super clear after the lecture.
Thank you.
Anyways.
Yeah, thanks. But probably because it's the first week.
No, because I don't know, because I'm lecturing two courses. For that course, it's exactly the same, and the students are accessing the, but I'm not sure. Let me double check again.
What other course do you lecturing?
Comp 9321.
Okay, 9321.
Yes, data.
Yeah, I'm the student of that class as well. Yeah,
yes.
but I saw the video of 9321 today, but this course I don't know.
Yeah, because I've done this, both of them. I'm not sure why this one is not showing. Because for me, but unfortunately, because it's definitely not gonna show. For me, it's showing because I'm the lecturer.
Wait, are you tutor of 9323?
9323, yes.
Yeah, I student of 9323.
Oh, so you're doing a lot of with me.
Oh, yeah. Oh,
For you.
see you next time.
9323 software as a service project.
It's one of the compulsory for AI, right? I think so.
I don't think so. Why would it be? Because it's a service-oriented architecture project.
Yes, yes. It comes after the other one, yes. I had a map, so yeah, I'll show you actually. You know, I know choosing this course.
Yeah, we don't have a we didn't put it as a prerequisite for anything, but if other courses decided to do that, it's...
Is it normal that asking that? Is it normal that I don't quite understand a lot of softwares that you just mentioned? So you're going to just brief overview for everything, right? That's why for next few weeks you can go deeper into
Yes,
something.
exactly.
So it's normal for me to...
Yeah, perfectly normal. Now it's just an overview so that you know. Because if you already know Hadoop, Spark, Elasticsearch, and NoSQL and HBase, because we are going to use HBase. So if you know all of these, then I would advise you go do something else.
Okay, no.
Yeah, because like here, this is what we are going to teach.
So that's the other one that I saw. So server storage is this one, right? Yeah, 932322.
No, Count 9322 is it's a software services course, but Count 9323 it's a project-based course.
It was called Enterprise Project, is it?
Yes, it used to be called
Yeah.
Enterprise.
I still have the old one, so yeah, okay. But yeah, so it's normal. Okay, I was kind of worried. I was up there googling on my phone everything.
No.
So,
Like if you're interested, you can definitely Google and get it, because these things we are gonna go through
yes.
little by little. But definitely, we don't expect you to know everything now, because otherwise you are better off with another course.
Yes, yeah. After yesterday's talk, I went home and did a search about different and then the other thing that makes me choose this is what it's that this course is not over next semester one. So that's why if I do a data service engineering, then I can't do this one next semester. So I swap it around. So if I do this, I can do data service next semester.
Oh yeah, it's up to you. So
you'd be interested to do this in Python, which should be easier.
Yeah, the thing is, like, there are some components that we are teaching here that are still in beta in Python, and I don't have tutors that are willing to take that.
Yeah.
So it's a bit of a hassle to either do that by myself, and specifically for beta tools, which might at some point stop there.
Google search I done with research I did yesterday. Apparently, there's still a lot of people doing Java, like 90%. This is at least 90% using Java, right?
Yeah, so it's like when it comes to Spark, there are a lot of people doing specifically Scala, But Java is still very relevant to Hadoop because it's like it was built in Java, so people are still more interested to doing that in Java. So Java is not dead by all means.
So it's good. Like
It is
I was
not-
thinking about it. It's also a good way to learn a language. Too.
Yes,
Yeah.
it's definitely like it's interesting and it is relevant in many cases. So it's not like it's useless and you're learning it for the course and that's it. But there are like many applications when it comes to programming your own bigger project.
Yes.
Java is very relevant. Python is good if you want something on the go or you have specific task, but if you want to develop for a larger scale, then Java or even C becomes more relevant. But at some point it depends on the application. I wouldn't say that applies for everything.
Yes.
It depends on the application, what kind of software you're trying to go after.
Yes. Thank you so much.
Yeah, no,
Thank you for today too.
no
I'll see you next week.
Okay,
Yeah.
see ya.